So before I do the factorial example, I want to just first start off with a stream of infinitely many positive integers. Okay? Now, the issue with this at first glance is the fact that, again, the integer data type doesn't support infinitely many positive integers. Neither does the long data type. Well, there is a way to circumvent this, and we'll come to that. But even that solution has its own flaws. So, what is that, or what is the solution to this? Well, or rather, what's the solution to the overall problem? So, we're first going to create a stream of longs, because this is going to be like our first take at trying to solve this problem. Okay, so let's create a stream of longs, and we'll call it positive integer stream. And we're going to use this iterate method. Okay, so the way the iterate method works is we will so it has what's called a seed value and then a stepper. Okay, and the way it works is the seed is basically the starting value. The stepper will take the seed, so some number n, and then do something with that, and then it's going to pass that back into this for the next iteration of the method, or the lambda expression, whatever. So for example, if we say that the stepper expression receives a value n, and then it returns n plus 1, then the next time we call it, it's going to set n to be that incremented value. So again, so let's say that we start off with 0, then we're going to get 0 plus 1. Okay? And then this is going to fit in here. So then we're going to get 1 maps to 1 plus 1. So then we're going to get 2 maps to 2 plus 1. And then 3 plus 1. Okay? And then so on and so forth. Okay? So again, the idea is that this is an infinite stream of these values, but they're not computed until we ask it to. So let's first pass in the value, and then we're going to say it receives an integer n, and then it returns n plus 1. Okay? Now, the issue here is that since we're using longs, we actually need to say that this 0 is itself a long. Because if we just have the 0 by itself, Java is going to say that that's an integer, and then this thing over here is going to get confused about that. Okay? So, now how do we take out positive thing, or not positive things, how do we take out numbers or things from a stream? Well, we've seen how to do this with the limit method, so let's say we want to get 30 of these numbers and then put them in a list. Okay? So this should be fairly straightforward, or this should be what you expect, right? So we go from 0 to 1, 2 to 2 to 3 to 4, all the way up to 29. Okay? Because we get 30 of them and start off at 0. Okay? So the iterate method over the stream class is what we're going to use in order to generate infinitely many factorial values. But there's one sort of issue with this. What happens when we overflow the limit of integers, right? Like, let's say we pass in, or let's say we invoke this stream infinitely many, well, not infinitely, well, yeah, infinitely many times. Eventually, we're going to hit that 2 to the 63 minus 1 limit, and that's not good, okay? So how do we sort of resolve that? The solution is to use something called big integer. Big integer is a way to represent arbitrarily large integers. So basically, a big integer can be as large, or it can represent as large of an integer or as small of an integer as physically possible on your computer. Okay? So you can literally create a stupidly large number, but eventually even this will crash with an out-of-memory error, because you're going to have, like, all of your memory is going to be dedicated to storing this value, and that's not good. Okay? So big integers can be really, really big. So it's like, ints are smaller than longs, but both of these are much smaller than the limit for big integers. Okay? So how do we create a big integer? Well, we can use the big integer class, and it even has some preset constants here. So let's say we want to start off our counter at 0. Now, again, this lambda expression is going to receive an integer, a big integer, n, and then we're going to try and do n plus 1 onto it. The problem is that you can't add anything to something that's not a primitive. So, fortunately, there's a method in the big integer class called add, and we can pass to it big integer dot 1. Okay? So this is going to look exactly the same because when we convert this into a list, it will stringify, so to speak, these numbers. Okay? So let's say we wanted to make this an alternating sequence, so to speak. So we're going to go from negative to positive to negative. Well, we can just say we're going to multiply this by, so let's say, or rather the question now is, how do we create a negative big integer? How do we create a big integer that's not one of the preset constants? Well, you can use big integer dot value of, and then just pass your number. Okay? So let's run this and see what we get. Okay? So that was not what I expected. Okay, so I'm realizing that this problem is actually slightly harder than I'm leading it on to be. So the way to do this is actually going to be, or is going to involve the ternary operator. Because how do we want to solve this? Well, we want to say that we want to add 1 to our existing number and then negate it. Okay? But the problem is that we want to, we don't want to just say -1, then +0, then negate this, because then we're going to run into the issue where we just go between 0, -1, 0, -1, 0, -1, like we just encountered. So what we can do is say we want to take the value as it is, take the absolute value of this, and then negate that result. Or rather, actually, this is not correct. So, what we want to do is take the absolute value of our number n, then add 1 to it, and then negate that. Okay? So let's see what that looks like. So we're going to take the absolute value of 0, which is just 0, and then we're going to get +1, then we're going to negate that to get -1. Okay? So then we're going to do -1 plus 1, which is going to be 2, but we need to have a case analysis here. So we can't just directly negate the number, because we want to say negate if the original number is less than 0. Okay? So how do we compare big integers? Because we can't just do like some big integer is less than another big integer, because these aren't primitives. But we can use its compare to method. Okay? So we can do some big integer 1 dot compare to some big integer b2, and if that number is less than 0, then this one comes before this one. Now you see where I'm going with this? What if b2 is 0? Then that means that this is negative. Okay? So what we really want to do is say, we're going to say, do this and not negated if in, or rather, we want to negate this result if n is negative. Okay? So, or rather, okay. I really should have pre-thought this. This is debugging on the fly. Okay? I did not think of this example before I started this video. Okay? So, if, let's say n is -3, we want the result to be +4, okay? Because the previous number was negative, and we want this to be, we want the result to be positive, okay? But if the number was negative, like let's say, or rather if the number was positive, then we want the result to be negative, okay? So what we can do is have a ternary operator. We can say if n is negative, and I believe there's a method in the in big integer that lets you do this, but if not, we can just do the compare to trick. Let's see, is there one? Well, there is a quick way to do it, but I'd rather not say what that is. So yeah, we'll just do the compare to. So if n dot compare to big integer 0, so if n is negative, then we want to say we're just going to take the absolute value of n and then add to it big integer 1. Okay? But if it's not negative, or if it is negative, then, or rather, sorry, if it's not negative, then we want to do n.abs.add. My cat is in front of the camera, so I can't see anything. Okay. Hello. Yes, everyone will get to see you now. Okay. So if it's not negative, if it's positive, then we'll do n.abs.add big integer 1.negate. Okay? So then we should be good. Okay? So, okay, this should be is less than 0. There we go. Okay. Now, this should work. It does. Very nice. So, yeah. So now let's actually walk through it. So if the number is less than 0, then we're going to take the absolute value of it and then add 1 to it. This will make it a positive number. If the number was previously positive, we're going to add 1 to its absolute value and then negate that to make it a negative number. Okay? So I realize that was a very sort of botched example, although not really. We got through it. In the next video, we'll have a much more prepared example where we compute an infinite stream of factorial values using big integer, because that's where we really start to see the limit of what longs, or rather we can see the limit of what integers and even longs can do.